Okay, so far for enzymes, we've talked about catalytic mechanisms, we've talked about mathematical models and kinetic parameters that describe enzyme behavior, and now what we're going to focus on is how enzymes are controlled, specifically inhibition of their activity and regulation of their activity. So we're going to start in this lecture video with inhibition. So how enzymes are inhibited and how those inhibition molecules affect enzyme kinetics. So we can take inhibitors and break them down into multiple parts. So the first way we can do that is breaking them down into irreversible versus reversible inhibitors. And we've already talked about this a little bit with our nuts and bolts activity we did at the beginning of this enzyme unit. So irreversible inhibitors lead to permanent inactivation of enzyme activity. So that means that once the enzyme's bound to the inhibitor, it's done. And there are two types. There are covalent modifiers of that enzyme. So a molecule comes in and somehow transfers, for example, a functional group onto that enzyme, covalently links it, which blocks activity. And there are suicide inactivators, which are kind of tricky molecules. So a suicide inactivator typically looks like the substrate of the enzyme, so it utilizes the enzyme's own catalytic mechanism to inactivate it. So essentially what happens is a molecule comes, the suicide inactivator gets bound to the enzyme's active site, the enzyme starts doing its regular chemistry with that suicide inactivator, but somehow during that process, an intermediate is formed to which no more chemistry can be done. So then the enzyme gets stuck and it's covalently linked to this random grouping of atoms that nothing can happen to. So that's a suicide inactivator. So reversible inhibitors, on the other hand, are in equilibrium. So they have some affinity for the enzyme and they can bind and come off. Those typically have non-covalent interactions with the enzyme. And we can break those down into four different parts. Competitive, which we saw in our nuts and bolts activity. Uncompetitive, mixed, which is a combination of the two, and non-competitive. And all of these four different types of reversible inhibitors differ in the way they affect the enzyme activity overall. They differ in how they bind to the enzyme and how they affect the enzyme's kinetic parameters in terms of the binding affinity for substrate, the Km, and the overall changes in the maximum velocity of chemistry that that enzyme can now do in the presence of that inhibitor. So we're going to go through these one at a time. But I will pause and do separate videos so they're nice and short for you.